Welcome to this edition of the Weather Class. Janetta Jones here at the Weather Channel, along with me, my partner, Vince Miller. Well, today we're going to be talking about a central subject, and that subject is wind. In our weather history, we're going to take you back in time only a few months and show you the devastation that occurred from Hurricane Andrew. And we'll show you what the power of Hurricane Andrew's winds did. We're also going to take you back in time to this winter, this past winter, show you some of the windy conditions that occurred along with snow and how that reduced visibilities gave people a little bit of a difficult time. Coming up in today's focus, we will explain wind, the different types of wind, and what wind can do as far as the weather is concerned. If you'd like to find out more about wind, well, you need to look in our book in Chapter 7, and we'll tell you more about it. Did you know that there have been some experiments conducted in search of an alternative to fuel? And wind is a very promising alternative. Take a look at this story from Dennis Smith.
Man has been harnessing the power of the wind for centuries. Today in California, more than 2.5 billion kilowatt hours of electricity are produced by wind turbines each year. That's enough power to supply a city the size of San Francisco. In fact, the largest wind east of the Bay Area in Altamont Pass. Here, a steady supply of summer wind begins with the sun. On a sunny day, the air over California's Central Valley heats up and rises. Cooler, heavier air from the bay is sucked in, turning the turbines. Experts believe that wind resources suitable for power generation exist in 37 other states, giving wind energy a promising future.
We'll have the answer to that question coming up, so stay tuned for that. Now, let's take you back in time and talk about wind, the power that wind possesses. We're going to take you back to Hurricane Andrew. You may remember that in August, Hurricane Andrew became the costliest hurricane of record for the United States as it whipped through Miami, Florida. This is what it looked like. The winds were clocked. Maximum sustained winds were up to 140 miles per hour as it made landfall in Florida. And at the National Hurricane Center in Coral Gables, they clocked a gust at 160 miles per hour, and that caused devastating damage, as you can see from these pictures. Later on, Hurricane Andrew moved on into Louisiana. Now we're going to take you back to January of 1992, show you Columbus, Ohio, when they picked up quite a bit of snow. Also, the wind was really whipping, so that made things feel really cold. The wind can do something called a wind chill. We'll be telling you more about that. Trust me, it can make you feel really, really cold, make that temperature feel even worse. And it can reduce the visibility at times to a half a mile in these particular instances and cause blizzard-like conditions, blowing all of that snow around. So those are two examples of what wind can do, one in the summer and one in the winter. Now here's Vince.
And in a few moments, we'll go ahead and give you some examples of just exactly what wind is and where we look for wind, and in some instances, why it's there to start with. But first, let's give you an answer we showed you just a few moments ago. Well, wind, yeah, that is the focus. So let's go ahead. Stream winds, we're going to take you way on up in the atmosphere, well, 4, 5, 6, 7 miles. Show you a satellite picture here, and at least you get the hint of what direction the winds are blowing from as we take a look at the, basically northern sections of the western hemisphere. Note the cloud elements here. This, of course, gives us a hint, in this case across the northern sections of the United States, that the winds at, let's say 15 to 20,000 feet in this instance above sea level are blowing basically from west to east, and actually they're blowing at speeds in some instances in excess of 100 miles per hour. These jet stream winds, by the way, were discovered back during World War II by bomber pilots going to and flying back from bombing missions over Japan. As they were flying against the wind, well, they were flying a lot slower than what they thought they should be flying. Didn't realize that they were flying against literally an invisible river of air. As they were heading from west to east, though, they were breaking all sorts of speed records. Again, not realizing that in some instances they were getting tailwinds of 100 to 200 miles per hour. But the jet stream, well, that's a subject for another weather classroom. Let's get more down to the surface here and go back to, well, one of our frames here and give you an idea of sort of the general circulation of wind across the globe. Of course, one of the reasons, the main reasons that we have wind is just simply what we call differential heating. It's the sunlight. Sunlight heats a surface. Air rises. If air rises, other air has to move in to replace it. Well, in our general circulation pattern, and let's sort of focus in here on the northern hemisphere, we can sort of divide the wind belts, if you will, into three more or less equal parts. The northeast trade winds, and in this part of the globe from, well, roughly the equator to about 30 degrees north latitude, winds generally are blowing out of an easterly direction, in many instances out of a northeasterly direction, but they don't have to be northeasterly. They can be southeasterly, and occasionally they'll have a westerly component, but this is the typical component of the wind, the northeast trade winds. Westerlies, and that encompasses most of the continental 48, well, these are winds that have a westerly component. They may be southwesterly, they may be westerly, they may be northwesterly, but it's the winds that tend to move our weather systems literally from west to east across the United States. Get on up though into the polar regions, let's say north of 60 degrees north latitude, and we get into the polar easterlies. And of course, in that instance, in most cases, the winds have an easterly component. That's typical, but again, it is not a hard, fast rule that that has to be the case constantly. Sea breeze winds. Well, in this instance, during the day, the land heats up faster than does the water. The air rises, and oftentimes we get thunderstorms over places like Florida during the afternoon hours in the summer. A little cooler air comes in from the surrounding waters and cools things off, at least on the beaches. In many instances at night, though, the reverse happens. The land cools off faster than does the ocean water, so that means we have the air blowing from the land to the ocean. We get our land breeze, and oftentimes it's not unusual to wake up early in the morning and see those storms way off in the distance. Now, if we show you the circulation of wind around pressure systems, low pressure systems, high pressure systems, well, note that L over Nebraska. Well, we're looking at a counterclockwise motion of the wind, northerly winds out there in the western high plains. Around the high pressure over western Montana and Idaho, we are looking at winds in a clockwise fashion, if you will. Well, let's go back to another type of wind. If we have an obstruction to the wind like a mountain, the wind can't tunnel into the mountain, so it's forced to rise. Clouds form, and oftentimes we get rain or snow on the mountains, but as the wind descends the opposite side of the mountain, it's not unusual to literally have a desert here, and that's typical of what we find in Nevada and east of the Sierras. Very dry air indeed in that section of the United States. Well, we told you a little bit about sea breeze. Let's give you a little bit more information with Dennis Smith.
If you're at the ocean, you may enjoy the benefits of nature's air conditioner, the sea breeze.
A sea breeze is a wind blowing from the water inland. What causes it? Look to the sun for the answer.
The summer sun heats up the land much faster than the adjacent water. The land heats, then heats the air above it, which causes the air to rise. As the air rises, it creates a space. The less heated air over the water rushes inland to fill that space. The rush of cooler air coming over you from the water is a sea breeze.
Another pleasant benefit of the sea breeze is that afternoon thunderstorms often form where the cool ocean air meets the hot, humid land air.
Because of the sea breeze, this usually occurs miles inland and keeps thunderstorms away from the beach. You may see the storms or even hear the thunder, but it probably won't rain on you at the beach. It doesn't happen all the time, but often during the summer, a sea breeze will keep your beach vacation cooler and drier. I'm Jeff Morrow.
Indeed, that was not Dennis Smith. That was, in fact, Jeff Morrow. Well, let's give you a little bit more information on. Look at this. We've got isobars, lines of equal pressure here, fairly close together. And the closer these lines of equal pressure are, the better the likelihood is that it's going to be windy. And in fact, in our forecast for windy travel, look at this. Essentially, where those lines of pressure, isobars, equal pressure, the closest to wind gusts in some instances at 20, 30, 40 miles per hour. Look at the isobars here. It's going to be a windy day. Strong southerly and southwesterly winds with this type of feature.